How do property tables help design energy systems? Imagine trying to build a machine without knowing how its parts work together. That's what designing energy systems is like without using property tables. These tables are like a detailed map for engineers. They give organized data on important physical properties of substances, such as temperature, pressure, specific volume, internal energy, enthalpy, and entropy. These properties tell us how a substance behaves under different conditions, which is essential for designing efficient energy devices. Let's start with the basics. Thermodynamic properties describe the state of a substance at a specific moment. For example, temperature shows how hot or cold it is. Pressure indicates the force exerted per unit area. Specific volume tells us how much space one unit of mass takes up. Other properties like internal energy and enthalpy relate to the energy stored in the substance. Knowing these helps engineers figure out how energy moves and changes in a system. Property tables include data for substances in different phases, like liquid, vapor, or a mix of both. For example, saturated tables list properties at the boiling point where liquid turns into vapor. This information helps engineers determine how much energy is needed to change a substance from one phase to another. This is especially useful in designing boilers, condensers, turbines, and other equipment. Using property tables makes it easier to identify the state of a working fluid at any point in a process. If you know the pressure and temperature, you can look up other properties like enthalpy or internal energy. This helps you calculate how much energy is transferred as heat or work. It also allows you to analyze phase changes and their energy needs, which is key for designing heat exchangers and systems that relying on phase changes. Another big advantage is that property tables provide reliable, experimentally measured data. This means engineers don't have to guess or estimate values, which can lead to errors. Instead, they can base their calculations on accurate data, helping optimize system performance, improve safety, and cut costs. For students and engineers, learning to read property tables is like learning a new language. It turns complex thermodynamic concepts into practical numbers that can be used in real-world applications. When you understand how to use these tables, you can better design and analyze energy systems, making sure they work efficiently and reliably. In short, property tables are a vital tool for designing energy systems. They give detailed, standardized data on thermodynamic properties, helping engineers understand how substances behave under different conditions. This understanding allows for precise calculations of energy interactions, phase changes, and system behavior, making thermodynamics practical and accessible for everyone working in energy technology.